Here is another example where we can kind of use everything we've learned so far about forces and inclined planes to figure out all these different parts. So really try to work through this one on your own. This is almost difficult enough for a quiz, or this probably could be on a quiz. It would be maybe an easier question for a quiz, but really take your time, press pause, take as much time as you need to try and work on this. If you're not sure what to do, start with the steps we've been doing. Draw a free body diagram, write your net force equations, and so on. So press pause, take a lot of time, and then press play when you're ready to go through it with me. Okay, oh, and this problem even tells you draw a free body diagram. It tells you what to do. In a question on the quiz, the way that I can make this a difficult question on a quiz is just ask for part D. If I just ask for part D, you would have to do parts A and B and C and then D. But it would be a much harder question because I wouldn't be telling you what steps to take. So think about that as you solve other problems on the homework. Think of all the steps that you're taking that you have to figure out what to do next. And imagine that there's like little instructions here telling you what to do. And then that's how you can approach those problems. So I'm going to start with my free body diagram. I already have the axes tilted. I have already split up my gravity into horizontal and vertical components on these tilted axes. Maybe now you're comfortable enough to just realize the normal force will be equal to mg cosine theta in this case. Maybe not. If you're not sure about that, just check the net force in the y direction. The net force in the y direction is n minus mg cosine theta. The net force in the y direction has to be equal to 0. Why does it have to be equal to 0? Because the net force in the y direction is always equal to your mass times your acceleration in the y direction. This y direction on this picture would be this direction like this, and the object is not going to accelerate in that direction. If it accelerated in this direction, that would either mean the block passed through the ramp, or the block like took off and started, flying out perpendicular to the ramp. That's not happening. The acceleration in this y direction, what I'm calling the y direction, is 0. That means the net force in the y direction is 0. That means my normal force equals mg cosine theta. Here I plugged in the numbers and solve for the value of my normal force. Now let's look at what's happening in the x direction. My net force in the x direction is equal to mg sine theta minus the force of kinetic friction because that's pointing in the negative direction. And here I've just plugged in what is the force of kinetic friction. It's equal to mu sub k times n. And here I'll just calculate these values. So how big is the net force in the x direction? I've plugged in all my numbers and I find that it's negative 6.24 newtons. That negative means that the net force is in this direction, okay, to the left. Or in this picture, that corresponds to being the uphill direction. So from this, I can take my net force and set it equal to m times my acceleration in the x direction. This is Newton's second law. Plug in the numbers that I know. I already know my net force in the x direction. I know my mass. And I solve for my acceleration in the x direction. Remember, this is that like fake x direction after I tilted my axes. In this picture, the direction I'm talking about for that negative x direction will be uphill. Okay, so finally, I know my acceleration. Now I need to calculate how long it's going to take. So now this is kinematics, right? Please, I want you to recognize this is kinematics. How long? That's asking about delta t. I want to know delta t. So think about your kinematic variables. I know a sub x. Look at this. I know v initial, and that 2 meters per second is down in this direction, right? Downhill, which corresponds in this picture to going to the right. So I could say v initial x equals 2 meters per second. And I just want to know how long it takes to come to rest. That means v final is 0. So here's my kinematics. I know my acceleration. I know v initial, or v0, my initial velocity. I know v final. I want to know delta t. I choose the equation that involves those 4 variables, plug in the numbers, and solve.